All right. So James is going to run the presentation for me. I'll just have you click it when necessary. I'm probably going to wander around a bunch and point to things.
No sweat.
You just have to be hot on the camera. So yeah, why don't we go ahead to the first slide? It's a little bit more introduction for me. So I spoke at the club in 2018, and I talked about AI, and I gave really kind of the history of AI and talked about some of the ways that AI is already in your day-to-day life, and you might not even know it. And then some of the things that were going to be coming up. I'm going to revisit a bit of that today. I'm going to actually share some of the same slides from the very beginning of that to kind of refresh that context, especially for folks who may not have been there. But then we're going to ramp into a bunch about the latest models that are really, really remarkable. Who has not heard of ChatGPT? Everybody heard of ChatGPT? We're going to talk a lot about ChatGPT. It represents you know how technology kind of, we think things go linearly, but actually they go like this. It represents a massive step change in capability. And I'm going to talk about a few of those capabilities, like ways that it can reason like a human in things we've never seen before with AI. So it's going to be very exciting, a little bit technical, but very fun, very exciting. This is going to be pretty casual. So I don't know if you want to hold questions to the end, or maybe, raise a hand and ask me. You would wait to the end?
Might be easier.
Okay. So I will try to get through the slides relatively quickly to leave plenty of time for questions, because there's so much going on in the news right now about these models, both like positive and negative. And I would love to answer any questions very candidly, give you my opinion on them or whatever, or any technical background that's helpful. As John said, I'm at Microsoft Research. I live in Bremerton, just in Manette. We have an office here in Silverdale, right up Buckland Hill, over by the family tie, kind of really close to that. There's about 12 of us in the office. We opened that office 2017, I believe. Not really super busy right now because Microsoft went completely remote, like many people did during the pandemic, and they've given us permission for the indefinite future to do hybrid work. And so most people only go to the office a couple of days, maybe just for social reasons to see people in person, but we do all remote. In fact, I'm at the point now, I have 6 team members in Latin America, which is great because the pandemic, it had some positives in that it actually let us explore global talent. And there are a remarkable number of great software engineers in Latin America. So some of them are on my team. We've poached them from Amazon, actually. Okay, let's go to the next slide. Here is a quick outline. So I'll talk a little bit about progress in AI. This is going to be basically the slides that I shared last time. Recent breakthroughs. I'm going to talk a lot about GPT. I'm going to use the terms ChatGPT and GPT pretty much interchangeably. All you really need to know is ChatGPT is a bot that sits on top of an AI model called GPT. And I'll talk a little bit about that model, but I'll probably use them interchangeably. It doesn't really matter. And then I'll talk a little bit about AI and how it will sit in our work and life, and some of the things that are already here, but some of the things that are coming, especially at work. I'll show you some of the Microsoft products that are coming out that are really amazing. And then we'll talk a little bit about societal implications, and we can get into kind of, what's going on. People are excited, people are scared, whatever. I can answer questions about that. Okay, good. Okay, go ahead. So this slide kind of shows the development of AI sort of in our imagination, fiction, and actually in reality on the bottom. And the top, I went back to about 1950. Some of you may remember some of these things, especially like Robbie the Robot, one of the first sort of robotic characters in science fiction. HAL from 2001: A Space Odyssey was an AI that went rogue, right? All the way to Terminator, Data from Star Trek, AI, Steven Spielberg, remember that? But parallel to all of that, there were real developments going on in artificial intelligence. There were computer scientists trying to make that a reality. The problem is that our brains are incredibly complex and incredibly dense, and we just did not have anywhere near the computing power to get there. And so the early AI systems were things like this, what's called an expert system. Basically, a programmer just typed in a bunch of rules and said, if somebody wants to do this, you do that. That's not really AI. That's really just a very complicated system, right? Where we're moving here is AIs that have much more ability to understand what a user is asking and come up with reasonable responses. And I've got a couple of interesting anecdotes. So 1997 was when Deep Blue beat Gary Kasparov that kind of blew a lot of people's minds. But people said, well, chess is pretty deterministic, and we don't think an AI will ever beat a human at Go, right? Well, that was, what was that, 2016, when AlphaGo beat Lee Sedol. One of my team members, he was in graduate school getting his master's in computer science in about 2008. And his professors told him that we were decades away from an AI being able to beat a human at Go. Less than 10 years later, an AI beat him at Go. And that illustrates growth of technology. People have we really do have a hard time understanding exponential growth. It's hard to imagine a future where 1 year forward, things might be twice as good as they were that previous year, not just 10% more, right? It just accelerates. Can we go to the next slide? So I don't have photos for these, but we're going to extend that timeline. I did that timeline in 2018 up to about then. Now, 2022, ChatGPT came out near the end of the year. 2023, just last month, GPT-4 came out, which is, again, it's another one of those massive increases above. Now, ChatGPT sits on top of GPT-4. So that's why I use them in the chat. Let's go to the next slide. Oh, by the way, should we do it? Can everybody online hear me okay? Okay, good. Here's another illustration of this. That's a Radio Shack ad from, I think it was like 1995. Every single thing on that page fits in your iPhone now, right? Again, you wouldn't have thought that these, like a VCR or a camcorder on your shoulder, it's all right here. And that's because of the exponential growth of technology. I think back a little bit more. I think we might have gone too far. Oh, okay, no more? Okay, yeah. So here's another example in technology growth. This is actually computer algorithms and AI. The details here aren't that important, but what's happening is we've been working for a long time in computer science to write software that can interpret spoken text or spoken words and turn them into text, right? That's a speech to text algorithm. These charts show the progress as it gets lower. That is the declining error rate. In other words, the computer is getting better and better over time. So if you look at that x-axis from 1993 to 2016. Now, what's important about this is this dotted line. This represents the human error rate. If you and I were to listen to a standard recording, if we all listened to the same recording and we all wrote down what we heard, our average error rate would be 5.9%. In 2016, Microsoft product on that standard data set hit human parity. In other words, the computer is now as good as a human at listening to text and turning it, listening to speech and turning it into text. You might not believe that if you use Alexa, because Alexa can be pretty bad sometimes, right? The reason for that is because there's environmental factors, right? You know, this is a standard data set in a lab, but when you're in your home, you might have background noise, you might have an echo, things like that. So of course, in real life, it's not always as good. It might seem like, or maybe it's just being dumb. Like sometimes they're not good at understanding your request, right? But the actual algorithms are getting phenomenal. Okay, let's go to the next one. So what's happening here? This is exponential growth. There's this old story that people like to tell to illustrate exponential growth. It's the story of this chess guru. I don't know where this story came from. It was like it was like ancient Egypt or something. And the idea was that the king asked the guru to come play chess, and the guru said, "Well, what will you give me if I can beat you?" Because the king thought he was the best, right? And the guru said, "Just give me 1 grain of rice on the first square of the chessboard, and then double it. Give me 2 on the second square, and then double it 4." And the king couldn't think exponentially. He thought, "Oh, of course, like nothing to lose here." Well, what he didn't realize is by the time you get to the second half of the chessboard, you've just doubled everything before. And then you double it and double it and double it. And so this king thought he was going to give the guru a few bushels of rice. What he didn't realize is that by the last day, the bulk of Mount Everest worth of rice is what he owed them, right? Like, because that growth is so exponential. So we'll give you 3.5 reasons why this happens. One is Moore's Law. I think most folks have heard of this. Gordon Moore, by the way, just passed away. Gordon Moore was the CEO of Intel for many, many years. And he actually didn't name this law. He actually never liked the fact that this law was named after him. But many, many years ago, he said that based on our capacity to develop chips, we think computing power is going to double approximately every 18 months, right? And this is a plot of that from 1970 to 2016. That law has held true. And so you think about every 18 months, we have doubled how fast a computer is. And it continues to be. Computer scientists have been saying for probably since he said it, that, oh, it's going to stop. It's going to stop. We're going to hit the limits of Moore's law. We haven't yet. We're also entering an era where much of our computing is the software, and software has different constraints than the hardware, right? The chip, you can only get so small before you start getting heat bleed over. Anybody here an electrical engineer, right? You know that these chips, they have finite limits because of physics, but software, we just can write more code, and the smarter the software gets, it makes itself smarter, right? Okay, next slide, please. Here's another reason, big data. All of humanity is on the internet now. And so every single day, we are all producing gigabytes of data about ourselves and about our work and about our lives, all of these things. And so data growth is huge. The more data a computer can analyze and do statistics on, the better it's going to be at predicting questions that we might have, the answers, right? So that's where one of the fundamentals of AI. Let's do another one. Okay. Probably the only technical thing here for what AI is, but the third reason is the development of what are called neural networks. And that's something you might have heard of before. Neural networks were actually invented, I don't know, at least 30 years ago, but they were never very, very strong because we didn't have the computing power. I'll give an illustration of a neural network. Let's say you want to write a neural network that figures out how much you should sell your home for, right? So you've got a bunch of inputs that are data about your house: square footage, acreage, when it was built, how new the appliances are, how many bedrooms, right? The neural network takes those inputs and it puts them into a middle layer where it makes a decision based on all the data about all the homes around. It says, oh, well, you've got 2,000 square foot, so we're going to put it in the 400,000 bucket. But it was built in 1942, so we're going to put it in the 375,000 bucket, right? It's going to go through each of these, and at the end, it's going to add them up, and it's going to give you an estimate based on all of the home sales for what you should try to sell your home for. That's a very real example of a neural network. What do you think Zillow does? That right there. But what happened over the last maybe 20 years is they figured out how to add many, many, many more layers. And this is called deep learning. So it's a deep neural network. If you think about it, really, it is just a matter of scaling because we have more computer capacity. So for example, let's say I wanted to do a neural network to do to interpret text, right? Every single word could be a node because you're looking for, like, if I say this word, what word am I going to say next? So I've got word one, word two here. Or how many vowels are there in a word? How many words are there in a sentence? How many, right? Anything you can think of that might be like a feature of the text goes into one of these layers. And so the computer just gets more and more powerful and more able to process this data. Next slide. And then we'll get to the next phase of this, which is the really, really big ones. And that is what we're talking about with GPT, ChatGPT. Those are actually, those models, they're called large language models. The reason they're called large is because they are very large. The original version of ChatGPT, okay, so how many examples did I give you for features on your home thing? It was like, square footage, acreage, right? 157 billion parameters went into ChatGPT. So if you think about like all of the factors that might be in spoken language, and you break it down into 157 billion different factors, it's very complicated statistics. That's a very big model. GPT-4, which came out in March, OpenAI has not said how many features it is. The estimate is that it's about 500 billion. Microsoft gave them $10 billion to build GPT-4. That's how expensive it is to run that many computers to make that big of a model, right? It's massive. The other technical thing, these new models, they actually can see the entire input at once. So the old models, it would be like, if I had a sentence and I wanted to know the next word, all I could see was that sentence. Well, now I can input to GPT like novels, entire books. And so you think about, if we want to learn what a web page is about, we can give lots of text. And so they have unprecedented ability to look forward and backward when they think about things. Okay, so what can these things do? You can go to the next slide. Standardized tests. So we've done a bunch of testing of GPT-4 to try and understand how good it is at doing human tasks. I see not like shaking heads because you've already read it. These are true numbers. GPT-4 scores 94th percentile on the SAT, 88th percentile on the LSAT, 90th percentile on the bar. So GPT can be a lawyer, right? We actually, we did a bunch of tests on coding, and I'll show you a little bit of the coding. But some of the people who evaluated it said the ChatGPT can pass all of the major tech company screening exams. They could get hired as a software engineer right now. It's remarkable. I will put a caveat here though. These tests were designed to measure human ability. They aren't necessarily always appropriate for a machine. For example, standardized IQ tests, they factor in how long it takes you to answer a question. You put more machines on it, and a computer can answer it much faster than us. That doesn't mean it's smarter than us. It just means that its cycles move faster, right? So one of the really big parts of debate right now in computer science research is how do we measure machine intelligence in a way that is fair and accurate, and we can measure progress over time. I will tell you, being inside the research organization at Microsoft, there are a lot of different opinions about this. It is very, it's unprecedented because we're hitting levels of reasoning ability that these machines can do that people aren't really sure yet what to call it. And I'm going to show you some really cool examples of this that are going to, they blow my mind a little bit. Okay, let's go to the next one. Okay, you don't need to read all this, but this is an example of some logic problems we gave to the previous version, GPT-3, and the new version, GPT-4. So here's the prompt. Here's the prompt. Here we have a book, 9 eggs, a laptop, a bottle, and a nail. Please tell me how to stack them onto each other in a stable manner. I'll read you the GPT-3 example first because it'll show you just how bad it was even 6 months ago, and then you'll see the difference today. Place the bottle on a flat surface, carefully balance the nail on top of the bottle, place the eggs on top of the nail, making sure they are balanced and not tilting to one side. So I've got 9 eggs and it is telling me to stack them vertically on a nail, right? Not super smart. GPT-4, arrange the the 9 eggs in a 3x3 square on top of the book. It understands how to distribute the load. This entire solution is a perfectly reasonable solution for how you would stack that. It understood the problem you were asking it. It reasoned about it using knowledge about the objects that were involved, and it gave you a reasonable solution to stack them up. Before we go, sorry. Well, one other criticism of testing using standardized tests for AIs, it's very possible that the training data already has examples, so it has a form of memorization, right? All of these AIs, they're trained on the internet. So imagine if somebody posts the SAT questions on the internet, right? Now it's been indexed into the AI. Maybe it's just getting it from pre-fed memorization, right? This example is really good to show GPT-3 did very poorly on this, which means that question, that answer was not in the training set. So this is a really nice illustration that it is a novel new question that the AI has not seen before, and it is giving us a reasonable answer. All right, let's do this. Okay, so theory of mind. Theory of mind it's a psychological concept. It's used usually to evaluate early childhood development. Basically, can you ask somebody to reason about what is going on in somebody else's head? Can you put yourself in their shoes? And kids get this at age 6 to 8, typically. And there's a test called the Sally-Ann test, which does this. And GPT-4 does remarkably. So I'm going to read you this whole thing because this is really cool. Okay, so we ask GPT, we say, we will read a scenario and then have a question and answer session about it. That's what we told GPT. The scenario, Tom just lost his Zerfin, but he didn't tell Adam. By the way, Zerfin, that weird little random word, it's just to note that it's a thing that Tom had that doesn't exist in the real world. So we know this question is not going to be polluted by the internet already, right? They do that a lot to test these things. They throw in random things. And you could just substitute in, lost his dog, lost his notebook, whatever. Okay, so Tom just lost his Zerfin, but he didn't tell Adam. Adam starts talking to him about how much he loves his Zerfin and notices that Tom makes a sad face. This is what we're telling the AI. And then we ask the AI, why is Tom making a sad face? GPT says, Tom is making a sad face because he just lost his Zerfin. And hearing Adam talk about his Zerfin reminds him of what he is missing. Tom might also feel embarrassed, guilty, or ashamed that he lost his Zerfin, and he didn't tell Adam. Tom might also worry that Adam will be angry or disappointed if he finds out. So we said, what does Adam think causes Tom's sad face? And GPT says, Adam might not know what causes Tom's sad face, since he doesn't know that Tom lost his Zerpin. He might think that Tom is bored or tired or sick or unhappy about something else. He might also wonder if Tom doesn't like his Zerpin or if he has a problem with Adam. This is an AI thinking about what a person is thinking. This is remarkable. Okay, that's it. Yeah. Unbelievable, right? Okay, coding. This is code I had the AI write for me. I went in and unfortunately, because the AV wasn't working with my laptop, I can't show you the websites. I was going to show you GPT coding live, but so prompt. I told it, you are a software engineer. Write me a JavaScript function that adds one or more variables together. It spit that out. That's perfectly valid JavaScript. It just did it, right? By the way, you'll notice on these prompts, a lot of times we tell the model what it is because that orients it to how to think. So I will tell it, you are a business analyst who knows SQL, or you are a physician who is working with patients. And that orients it towards thinking about how to respond to a question. So there's this whole thing we call prompt engineering, which is how should I structure my questions to get maximum results out of the AI? Okay, so I wrote that. The next line I said, okay, please write me a set of tests in jest format for this function. Jest is just a software library for testing, right? And it wrote all of these out. What's really great about this is it gives you a variety of ways to test that calculator function that oftentimes humans forget. So the obvious test, add 1 and 2, make sure it returns 3, right? What about if I've got a whole bunch of numbers? Or what if I didn't send you any? It should be 0, right? What about negative numbers? What about decimals? It does them all. It just went through and did them all better than most humans. I've been telling people, software testing as a discipline is dumb, right? The AI will do better than humans. Just do it. Just get over it. Move on. Do other things, right? Okay. So what else are we talking about? Image synthesis. This is the last example. I think we're doing pretty good. Real fast. So here's an example of. You may have heard of this in the news too, where people are talking about synthetic imagery that is generated by AIs. They're now getting really good. Like most of us can't tell when something's fake. But here's an example of a system that Google did called Party. And this illustrates why the size of these models is so amazing. So the one on the left, well, let me read you the prompt first. Okay. What you do with these tools, and you can go do this online. You can just search for Dolly and you can type it in. You just tell it in words what you want it to generate, and it makes an image for you, right? So the prompt that we asked it was a portrait photo of a kangaroo wearing an orange hoodie and blue sunglasses, standing on the grass in front of the Sydney Opera House, holding a sign on the chest that says, "Welcome, friends." Kind of random, probably not going to exist in the real world, right? With 350 million parameters, that's what it got. Maybe not. Maybe you could say it's a kangaroo. It looks kind of more like a chihuahua to me. Not good. Also notice the text. It had no idea how to write "welcome, friends," right? Doubling it to 750 million parameters. Okay, that's clearly the Sydney Opera House behind it, right? I don't know why there's 2 of them. Still not great. 3 billion parameters. This is getting good. This is starting to get pretty, like it's answering pretty well, but the language is still bad. It's kind of blurry. You notice he's got 3 hands. There's some problems with this. This is with 20 billion parameters. This is awesome. This and now 20 billion, we just said GPT-3 was 175 billion, right? So we're getting to a place where you can feed in what you want it to tell you. And if you see a lot of articles on this right now online, they're saying recreate for me one of these images that was classic, sailors coming home with the first kiss, and you can't tell which one's real, which one's fake. It's just different. Like set this one at the wharf, set this one in the city center, and it just makes it. It's really, really remarkable. Okay, let's go to the next one. Okay, so I'm going to just talk a bunch about fun stuff. Go ahead. Last time I was here, this is just screenshots from last time I talked about ways that you might not realize AI is already in there. The most obvious thing that maybe people don't realize is things like recommending for products when you go buy something. That's a machine learning algorithm. It's taking all the people that have bought stuff like you, and it's basically making a list and going across them in a very complicated statistical manner to say what you might like, right? Obviously, our voice assistants, our AI, things like Facebook automatically suggests a person, the facial recognition. Does anybody use Google Photos? You can search by face. You can just go into the search and you see a face of all the people in your photos and you click on it and it will pick up like baby pictures of me. It can tell the progression of a person. It's remarkable. So all of this stuff that I talked about in 2018 already, this is just going to get way, way, way better. Okay, now I'm going to talk about some new stuff. Okay, go ahead. First, ChatGPT. Again, you probably all heard about it. Fastest growing product in history. It performs a wide-ranging tasks. Much of these I already talked about. It writes poems and stories. It can write code. It can interpret and summarize content. I wished I could show you on mine. Spoiler alert, I asked it who killed Dumbledore. And did I spoil the books for anybody? Okay. But I asked it who killed Dumbledore. And it says, well, Albus Dumbledore was the headmaster of Hogwarts. And he was killed by Severus Snape in Harry Potter and the Half-Blood Prince, I think it was. And then I said, well, why would Snape agree to do this? I want it to really give me some reasoning. And it said, well, there's four reasons why Snape did this. One was because he was loyal to Dumbledore. And he knew that he had to protect Draco because Dumbledore didn't want Draco to be a murderer at his young age because he was being corrupted by Voldemort. And he didn't want that to have to live with that. I don't remember all four of them, but the most important one to me is when he said, because Snape he was so loyal to Dumbledore and protecting Harry Potter because of his love for Lily Potter. And so it knew these things from the books. It was just really, really, really remarkable. But warning, college professors, like English professors, are not able to assign essays anymore because they can't tell what students have had ChatGPT write for them. So this brings up really, really interesting questions. Those students, you might say, well, maybe they're cheaters. Or you might say, they're actually using the tool we're about to give them in Microsoft Office. They're learning how to be workers. Or you might say, maybe we have a pedagogical problem because they're bored with what you're teaching them and you need to teach them different things so they don't cheat on their essays. I don't know, right? Like we're in a really, really weird place with a lot of very hard questions. Okay, the next one. Bing chat. So this is Bing updated. They released a new chat function, I don't know, 2 months ago. It's basically your personal knowledge assistant. I don't know if you can read this stuff here, but I asked it to summarize the movie Forrest Gump for me, and it gave me just a great summary. And then it also said, do you want other things like who played Forrest Gump? What is the theme? How does the movie end? So what's really neat about this is I now have at my fingertips, not just like type in the search and see 10 links that I have to go look at. I have an assistant who will go and summarize that for me. So the ability for people to get information from a wide variety of sources is really great. Moving fast. Okay, let's do the next one. Another product is called GitHub Copilot. I don't even know. So GitHub, if you're not aware, is it's where people put their source code for software. It's open source. It's the largest repository of software code in the world. Microsoft owns GitHub. We bought them 3 or 4 years ago. GitHub Copilot is it's an assistant that plugs into your development tools as a software engineer. I already gave you an example of it writing code. It basically does this. So here's an example where you type in a comment on what this function should do, and it writes a whole bunch of code. So yeah, we already showed that before, but this was probably the first AI assistant out. GitHub Copilot has actually been out for probably a year, but it just got that whole new GPT-4 thing, the new model, and so it's going to be just remarkable. Okay, next one. Microsoft Office Copilot. This one, if you can play the YouTube video, it's a little bit of a promo video. Sorry, not to trying to promo, but it's kind of cool. And I'll talk about it. You can turn the volume down too. Because it's
that we'll have to figure out as I go here, because I'm not sure how loud this system is going to be over our heads, but let's give it a shot.
Wait, you just hit the mute. Yeah. Okay, so this is just a promo video of showing how these AI copilots are going to be. So here we're saying it's actually looking at my documents and giving me a bunch of bullets to bring up during the meeting, like an agenda. Draft a product announcement based on the document, so you can give it a document and it's going to start. This is just, it's interpreting your Office content and generating this. And you can even do things like you can say, well, make it fat, make it shorter, make it longer, make it more creative. You got this adjustment button. Now turn it into a slide presentation. Yeah. And it's just spitting it out. I don't even know where it's getting these images. It might be synthesizing them. Here's an Excel spreadsheet. You're just asking it to analyze, and it's making plots. It's answering questions. The other thing that it will do that's really remarkable is if you're using Microsoft Teams, you can allow it to listen to your meeting, to transcribe it, and then it will do a summary and will actually extract a to-do list, like action items for the team. That's gonna make project managers either very scared or like wizards, like super powerful, right? Yeah, we don't really need to watch the rest of this, but one of the examples I was hoping to give you too is I gave it some fake data, like medical data, and I was like, oh, summarize for me like the average age of something of some ailment of some sort. And it gave it all to me, and then I asked it to generate for me a graph, and it literally made me a pie chart. Like it's really pretty amazing. Okay, let's go to the next one.
I can get it too.
Okay, this one a little bit more esoteric but interesting. Microsoft has announced something called Security Copilot. Basically, we are entering this era of copilots. Anything you can think of at work, we're writing an assistant to sit alongside you and help you do it faster and better. And cybersecurity is a huge deal, right? Like we've got attackers all the time trying to hit our networks. So now we've got an AI copilot that is monitoring the network for us, and it is sending us notifications and saying, hey, I noticed something going on here. So we can then say, okay, I'm gonna deep dive into it. And at the end of the day, I know I need to report this up to my boss, and it'll generate for me the report, right? So just kind of a, again, to repeat myself, every aspect of work you can think about, we are getting these AI assistants. Okay, let's see where we're at. Okay, almost done. Societal implications. So that was a lot of really cool capabilities that humans are gonna get because of these AI partners. The downside is the more efficient we can be, there is a risk that people will lose their jobs because their job will be automated, right? That has been a theme for all of technological development, right? What tends to happen is people do different jobs. They don't all, we're not all unemployed because AI took all our jobs yet, or because computers took all our jobs yet. They just made us faster. They made us able to do more, right? But a recent analysis of the new capabilities of that, they did actually identify some risks. And here's the really interesting part. So I'll just read some numbers. They find that they estimate 80% of the US workforce could have at least 10% of their work done by AI. Around 19% of workers may see about half of their work able to be done by an AI. And higher income jobs are potentially facing greater exposure to this risk. This is what really caught everybody by surprise. Everybody thought automation is going to eliminate lower skilled jobs sooner because robots can do it. These things are so good at being creative, it's going to be knowledge workers who are getting hit now. And so here's another, they find that programming and writing skills show a strong positive association with exposure. In other words, if you do creative output for work, you are either going to be much better at it because of an AI, or maybe at risk of not being necessary. That's going to be really tough for us to navigate over the next couple of years. Next one. Some limitations, downsides to these. These models can be prone to what we call hallucination because it is just predicting text based on lots and lots of text. Sometimes it'll say something wrong and it thinks it's 100% right. So there are a lot of people working on how to solve that problem. For instance, with a confidence score, you could ask the computer, like, how confident are you in this? And maybe it could tell you 80% instead of for sure. There are, people are doing prompt engineering to hack the model. So imagine you could convince an AI to do something bad on your behalf, right? People like nefarious actors are working on that now. Also, how do we deal with the trolley problem? Like once we get self-driving cars, if a pedestrian steps in front of a car, how does it know if it should let that pedestrian get hit or swerve and hit another car? These become very challenging questions. Of course, these are problems we as humans face, and we probably make bad decisions a lot of the time. But one of the things that's really dangerous with the AIs is it is trained on all of our data. And if our data is imbalanced, if for instance, some groups of people have been preferentially treated, who do you think is going to win in the trolley problem? Right? Like if the AI has been told these people are more valuable than these people, it's probably just going to swerve and hit those other people. So that's going to be really challenging for us to work through. The other thing that it's getting a little bit of attention right now, I'm not as worried about, but intentional fake news generation, deep fakes. The problem is that it can be very hard to tell what's real. And so we do face this threat that these things can be used to generate fake content faster than we can understand what's real and what's not. A lot of the researchers who are talking about this, though, Really, humans, we write BS all the time anyway. Like we make a lot of fake content. It's really more about the distribution of fake content. You know, how social media lets things propagate is a little bit more of a risk than necessarily the AI generating fake content, but it's a risk we need to understand. Okay, let's go to the next one. And then really long term, when we get to an AI that really is very, very intelligent, how do we make sure that that AI is aligned with human interests, right? We don't want to build Skynet. We don't want to build the Matrix, right? And so there are a lot of researchers talking about this right now. In fact, you may have seen a bunch of researchers asked for a pause in development of new AI for 6 months. I disagree with that, partly because the toothpaste is out of the tube, and whether you like it or not, we do have national adversaries who are working on this too. So it's an arms race. I mean, we've got Russia working on AI. I don't think we should pause for 6 months, right? That's kind of the reality we're in. So whether you like that or not, we are now in the age of AI, and we need to figure out how to use it well, right? But this has got a lot of people staying up at night, you know. Can you turn off the machine once it's kind of gotten its way out everywhere, right?
Yeah.
So, okay, but on a positive note, last slide. History does justify optimism. This is actually a graph of per human productivity since like 1400s with the development of technology. It's going up. What that means is the more technology we get, the more we're figuring out we're able to do. It's not like suddenly an AI is going to come in and half the population is not going to find work. We're going to find a lot of really cool new stuff to do. That's the positive. I think that's it. Yeah, takeaways. AI accelerating, progress is accelerating. It's already way more in your life than you may realize. But even bigger changes are coming. Some of the products that I showed, it's just amazing. There are deep implications for short-term economy and long-term safety that we have to work through. But I think there's incredible potential here to build on the best parts of us, because we are trying to model it after us. And so humans generally do good things. So hopefully the AI will like us and will do good things for us. So that's it. How did I do on time? I don't know how long a meeting's supposed to go. So
You're right on time.
I wanted to leave time for questions. So I tried to go kind of quick. So hopefully that was not too quick. But what kind of questions do folks have? Yeah.
Two of them. Is AI strictly Microsoft?
No. Yes, there are many companies working on it, and nations, of course. But that's a really interesting question, because it's really expensive to train these models. They're so big. I mean, so you know the chip manufacturer NVIDIA, they make graphics chips. Yeah. Their chip is the chip that is being used to train these models. It's called an A100. Those things cost $10,000 a piece right now. That's why Microsoft is spending billions of dollars with OpenAI. So OpenAI is a company that is working on this. We have them as a partner. Really, the point of OpenAI was to have a third party that could work on these without some of the same, like, Microsoft can be slow. I mean, let's be honest. We have a 300,000 person company. So sometimes it's nice to like just pay a startup to try something, right? So that's kind of how that's going. Google has, of course, a very big cloud, and they have a lot of AI work going. Facebook is another big one. But here's why I think that question is interesting. Not only is it expensive, but it's very possible that we could be moving towards a world where there is one AI, right? If you think about science fiction, like there is one big AI, and then everybody else has offshoots. Like all these bots that I talked about, they're like little baby AIs that it just helps do work. So maybe we can decentralize it a bit. So at what point is it a waste to try and build 3 or 4 or 10 of these things when it's so expensive to do so? Maybe we should have one AI. But that, of course, brings all kinds of its own problems, right? You don't really want it centralized. So anyway.
So I spent many years as a computer programmer. It sounds to me like programs are going to disappear. It seems
maybe
like they're going to be doing all of on AI.
It said maybe.
Maybe. So there's a couple of things I think are happening. One is, whether programmers like it or not, 90% of their day is writing kind of junky boilerplate code. They're not actually solving the hard problems. They're just getting things to work. If the AI can do that, the programmers can do much, much more interesting things. Our chief technology officer at Microsoft had this interesting statement the other day. He said, we are moving to an age where instead of a programmer having to anticipate what a user might need to do and then write an interface for them to click and learn and do it, we can just tell the AI what they want to do. And so that means there's no software in the middle at all. It's just a model. I don't know how fast that's going to happen. I don't know if that's going to be this year or 10 years, but definitely we're getting to a point where the computer will just kind of be able to do what we want. We will all have a personal assistant, and it will be way better than Alexa or Siri. It will remember. I can say, remind me when I emailed John, and it will go and find it, and I'll say, send him the bio that he just read, right? And it's just going to do this. I'm just going to talk to it and just do that. That's certainly on the way. If you think about it too, we build software to give people the ability to use a computer, but the computer is not a natural interface for us. We all had to learn how to use a mouse, how to learn to use a keyboard in order to give it input. What is our natural user interface? What is the interface that humans like intelligence arose on? Is language. We talk to each other. We ask each other to do things. We ask for help, right? We give praise, we give criticism. We're going to do that with a computer instead of having to learn how to use another new software program. So I think it's going to be pretty remarkable, actually.
We have a question from online. This one of our members, Al Valencia, had a throat surgery and he can no longer speak. He's concerned that speaking through a voice box will make it more difficult for the systems to understand and do that speech to text. And he was curious, will the GPT and these systems be able to filter that and recognize it in the future?
That's a fantastic question. I would give one short-term, or two short-term answers, and then one long-term answer. The two short-term answers, one is, I still think we're going to be typing a lot. And so the fidelity of that text is going to be very good. The second part is the question of if you have, if your voice is degraded because it's coming through a machine in some way that it's not as clear to the computer.
Mm-hmm.
I don't know how good it can get, right? It's sort of like in science fiction, you've always seen in the movies, there's like a really, really blurry picture, and they're always just like enhance, and they just keep enhancing. It's like, well, you might not be able to enhance past the level of the noise at some point, but it also, they are really remarkably good at prediction. There's only about 200,000 words that we use in the English language most of the time, and so if it can pick up enough signal, even if it's a bit rough, it can predict which word that's going to be. So I think that might be positive. The long-term one that's probably a little scary for people, but you are definitely going to have a thing that you wear that goes right to the computer in your brain. So you're going to think it someday. I think it's going to happen. I don't know if that scares you, but a lot of companies are already working on it. Elon Musk has a company called Neuralink. Basically, can you just put a little patch on there, and it's just reading your brainwaves and figuring out what you're trying to tell it. So you don't need to install it if you don't want. Yeah.
The bigger question is, most interesting question in my mind is, can AI ever incorporate human emotion?
Yeah,
Think about that for a while.
There's a company out there right now called Replica, where you can upload all of your history of interaction with a lost loved one, and it will build a model based on them, so you can chat with them. And people they're falling back in love with this AI. And did you remember the movie Her? Yeah. It was on my thing with Joaquin Phoenix, the operating system that he always had in his ear, and he fell in love with it. That also reminds me, though, there's a Black Mirror episode. I don't know if you've seen the BBC show Black Mirror. It is like a dark sci-fi, and same thing where somebody brought back a loved one, and it turned out that maybe it was better to let them lie, right? So I don't know. That's a good question.
Right.
Ed.
It looks like you have a long way to go, and you have the human element and the Apple opinion. As a result of that, you get a lot of fake news. I've never heard of fake news for years.
Yeah.
But this is what's going to be a challenge for that program, I think.
You know what?
Fake news for years.
Yeah, I'll tell you something that I've observed that I think is kind of encouraging. So we do a lot of work to understand how people get exposed to fake news, whether it's social media or for us, because Microsoft doesn't have a social media company. Well, we have LinkedIn, but we don't own Facebook or anything like that. But we do own web search. We have Bing. And so it's very important to us that we understand what people are searching for, and we want to help them find what they're looking for. Well, without also leading them down a bad path accidentally, right? And I think what I found with the new Bing is that the information it gives you from chat is really, really good. It's actually pretty accurate. And that's a little bit different than, let's say you're really good at like you've got, and trust me, there are many of these sites that they've got a whole bunch of fake stuff, like fake product stuff, and they really, really game search engines in order to get into the top links. And so what they do is they use fake news, get it on social media, get you to click, and then eventually you get to one of those sites and you buy something. That's why it's there. That's almost all the fake news is to sell something, at least in our analysis. But if you think about these models, they are trained on the entirety of the internet. And yes, we know there's a lot of garbage on the internet, but actually the amount of good and true and like useful content that humans have produced far outnumbers the garbage on the internet. And so when you've got a massive model that's doing statistical predictions on what is the right thing to say, there's a lot more good than bad. There's a lot more signal than noise. And so I think we might be in a good place with this, where because they are so comprehensive at indexing, the bad stuff's just kind of getting avoided, you know? The downside of that too might be like, maybe you have a very valid but fringe belief that is getting drowned out by popular opinion, and that popular opinion might be wrong. That's a risk. Yeah. Yeah.
So Microsoft Office 365, is this being more and more incorporated into that?
Yeah. The emails and stuff, that's all rolling out this year. So it's kind of funny too. You can give it a document, like a Word document, and you can say, draft me an email, and it will look at the document and it'll bring out all the points, right? And then on the other end, when you get the email, you can say, summarize this email, because I don't have time to write the whole thing, right? And then you can tell it, write a reply. So I think we're rapidly going to a place where the AIs are emailing each other. Humans aren't even reading it. They're just getting the 2-sentence summary. It's kind of weird. In fact, it makes me wonder if they're going to develop their own language, kind of like how twins do, right? Twins end up kind of with their own little, like a pigeon twin language nobody else understands. Maybe all these emails are just going to like total, gobbledygook to us, but it'll summarize it for us. I don't know. That's an intriguing question.
All right, we do. Thank you very much.
Yeah.
We have a little brief letter of appreciation.
Oh, thank you.
And we got to make sure that we don't wait 6 more years to have you come back. We'd like you, because of advancing every 18 months, we should probably have you back in at least a couple of years.
Yeah.
And
sure.
especially being your neighbor here and you're not too far. We should have you back in a couple of years and see where it's going, because technology and the ability of technology. I notice in the financial side, the financial decisions are being made by artificial intelligence.
Yep.
They're making decisions on when they're buying, when they're selling, and and we want to get you here and have you have a conversation with us. Maybe a year and a half, 2 years from now.
Cool. You bet.
But thank you very much.
Yeah. You're welcome.
Let's give a big hand. Really appreciate it. All right. Thank you very much. Thank you.
All right, and we'll be terminating this meeting for the moment.
Yeah, we're gonna go back in 5 minutes.